So for today's lesson, it's our 4-2. We're going to be graphing, which is why you guys have rulers today. We're going to be doing our part 1, which is going to be like a simple versions of graphing. So our objective says we can graph simple rational functions using the transformations. And so if you ever see the word transformations, these are the A, H, and K values. So if you remember, our A value tells you if it's a reflection across the x-axis. The H value on A also tells you if it's a vertical stretch, a vertical compression. Our H value tells you left or right, and K tells us up or down. So hopefully those are familiar to you guys. Hopefully that's ringing the bell when we did polynomials. So for our prior knowledge, I want you guys to determine the equations of the asymptotes. All right, so today we're going to be looking at asymptotes, and we're going to be able to graph something like this. We're going to learn how to graph the asymptotes, and then we're going to learn how to graph the curves, and then we'll figure out how to do that today. That's our end goal. So for concept, we have here, it tells you that the parent function for the family of rational functions, we got f of x is 1 over x. And so if you notice that variable is in the denominator, and so because the variable is in the denominator, and we talked about this on Friday, we are not able to divide by 0. So it is undefined when x equals 0, because you will end up with something like 1 divided by 0, and that's going to be undefined. You cannot divide by 0. And so the x equals 0 becomes undefined, which is where we get our vertical asymptote at x equals 0. There's also a horizontal asymptote at y equals 0. And then just for review, the word asymptote, that just means it's a line which a function approaches as the value of x goes to positive or negative infinity. It approaches the value, but it will never reach that value. Okay, so it's getting closer and closer to the line, but it's never going to actually touch or cross that asymptote. It's like a barrier. That's our wall. You're not allowed to cross that asymptote. It approaches it, but you can't touch it. It will never reach that value. All right, next we have, just for review, the A, H, and K's, like we did in the past. So our A value is going to be the value in the numerator. So if you remember the A value, if it's negative, that tells you we're going to have a reflection across the x-axis. If A is greater than 1, that also tells you it's a vertical stretch. If A is between 0 and 1, that's going to be a compression. Then my H value, remember, is in the denominator this time. Was always next to the x value. So in this case, rational functions ends up in the denominator. So under the line, next to the x, that's our H value. And so then we have, if H is less than 0, meaning negative, we go to the left. If H is positive, we go to the right. And then our K value is at the end. So after the fraction, you have a value at the end. And so if K is negative, you mean it goes down. If K is positive, we go upwards. Okay? And key things to remember, that's a negative H. So this is the opposite of our H value. So if H is positive, it becomes negative. If it's negative, it becomes positive. You will have to switch the sign. So I'm going to put in parentheses, we switch the sign for our H value. And so if H is negative, we go to the left. If H is positive, we go to the right. And I used to draw this for you. So if it's helpful, if H is negative, we go left. If H is positive, we go to the right. Likewise with our K value, if K is negative, we go down. Positive, we go up. So we can draw our arrows going up and down. Positive, we go up. Negative, we go down for k. And then this here means if a is negative, then we are going to flip it across the x-axis. And then we also have the equations of the asymptotes. And so when Mr. Maestas was here, I asked him to write the equation x equals h, y equals k for this specific reason. Our vertical asymptote that goes top to bottom goes with our h value, and it's at x equals h. And then the horizontal, the one that goes left to right, that's our y equals k value. Okay. So let's go ahead and look at our steps first before we do an example. Our steps to graph rational functions is first determine a, h, and k, and the transformations that they create, and then we're going to graph the vertical and horizontal asymptotes as dashed lines, and then we're going to transform the key points 1, 1, and -1, -1, and then draw each piece of the curve. Just like we did for polynomials, if you remember the 5 key points, we had -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. You guys had to memorize those. The same is going to happen here. You guys have to memorize these 2 points. Okay? It's just the ones that are positive and the ones that are negative. So 1, 1, -1, -1. It's not that hard to memorize, but I'm letting you know they are not given to you on the test. You need to know what those are. Okay? All right, so let's go ahead and look at our first example, but you guys need to copy it down. So go ahead and copy. G of x is 1 over x plus 4. All right, so if I look at my function, I have g of x equals, our a value is in the numerator, over x minus h in the denominator, and your plus k goes at the end after the fraction. Okay, so if I look at the function for g of x that I have, my a value is going to be in the numerator. So notice on top of my fraction, I have a 1. So that's going to be my a value. I have a is equal to 1. And so then I need to figure out, do I have a reflection, do I have a stretch, or a compression? And so because it's positive, I have no reflection. And then I have 1 that's not greater than 1 is not less than 1. So there's also no stretch or compression. Okay? So when a is 1, basically a doesn't really do anything to the graph. There's no stretch, there's no compression, there's no reflection. Then I need to look for my h value. So if you notice, h is going to be in the denominator next to the x. So underneath the fraction. So if I notice underneath the fraction, I only have an x underneath the fraction. I do not have anything next to the x. That tells me my h value in this example is going to be 0. And so since our h is 0, that means I don't go left or right. So there's no horizontal shift in this one. There's no horizontal shift. I'm not going to move left or right. But I do have a k value. My k value is at the end. After the fraction, k, we do not switch the sign. only for h. So my k value is going to be 4. It's positive 4. So my k value tells me up or down. Because it's positive, that tells me we go up 4 times. Okay, so that's step 1. Figure out A, H, and K, and what do each of those tell you to do to the graph. Then step 2 is to draw the vertical and horizontal asymptotes with the dashed line. So my equations for the asymptotes, one more time. My vertical asymptote is in x equals the h value. So I have x is equal to h, which h is 0. And then the horizontal asymptote is a y equals the k value. So my k value is 4. So I got y equals 4. Okay, so this is where you're going to take your ruler and you're going to draw your two asymptotes. And so if I look at x equals 0, I'm going to go on the x-axis, I'm going to put a dot and my 0. And I'm going to draw vertical asymptotes, so the one that goes top to bottom, but I'm going to draw a dashed line. So you're going to put your ruler, and I would use a highlighter maybe so you can, visually you can see it, it will stand out. So put your ruler, and then you're basically going to grab your highlighter and just put just keep lifting your pencil or highlighter to make your dashed line at x equals 0, okay? Especially because that's at the y-axis, basically, it'll be hard to see with just pencil, which is why I was suggesting a highlighter if you have one. It's not necessary, but it'll help if you do it in a highlighter so that it stands out. All right, then I'm going to grab my y equals 4. So now on the y-axis, I'm going to look for my value of 4. I'm going to put a dot just so that I know my horizontal line has to go through that dot. So horizontal is the one that goes left to right. Grab your ruler, and you're going to draw a dashed line at y equals 4. So that's a y equals 4 and an x equals 0. Okay, so that's my step 2. Step 1 is find A, H, and K. Step 2 is draw your vertical and horizontal asymptotes. Then step 3 is to take your coordinate points, 1, 1, and -1, -1. So to these 2 points, notice I have no stretch, no compression, no reflection, no horizontal shift. The only thing I'm going to do is basically take those 2 points and I'm going to move them up 4 times. Okay? So if I go to my point 1, 1 on the graph, I'll be here at 1, 1. And then all I do is move it up 4 times. So at 1, 1, we're going to go up 1, 2, 3, 4. And I'll end up at 5, 1. So I'm going to put a dot at 5, 1. And then I'll do the same thing with -1, -1. Go on the graph to -1, -1. And same thing, just move it up 4 times. So from here, go 1, 2, 3, 4. So I'll end up at -1, +3. And then notice my 2 points are diagonals from each other. They always have to be that way. You should not have them next to each other. They should be across from each other. Okay? So they'll either be on the top right, bottom left, or top left, bottom right. They either have to be across this way or across this way. If they're next to each other, that means you did something wrong. Okay? And then what you're going to do is grab your pencil. You're going to draw a curve. So next to the asymptote, to the point, and then end next to the other asymptote. Okay? So next to the asymptote, touch the point, and then down towards the next asymptote. You should put two curves. And then, like the two ends have to be right next to the asymptote. Not touching the asymptote, but right next to it. Likewise with this one, next to the asymptote, touch the point and then go downwards next to the two asymptotes. And then that's it. We are finished. Step 4 was to draw the two curves. Okay, so hopefully that was not too difficult for you guys. It's figuring out A, H, and K, your two asymptotes, and then A, H, and K tell you what to do to the two key points, and then just craft the curve. So let's go ahead and try another one together. Please copy the equation. We have g of x equals -1 over x plus 3. All right, we got g of x is -1 over x plus 3. So one more time, our function notation is g of x equals our a value in the numerator over x minus h, and the plus k is after the fraction. So my a value I can see is in the numerator. In this case, I have a as -1. So if you remember, what does that negative tell you to do to the graph? It's a reflection this time, okay? So I have an x-axis reflection. It's 1, so no stretch, no compression. All I have is an x-axis reflection. Then my h value, again, the h is in the denominator underneath the fraction next to the x. And so in this case, that plus 3 is in the denominator. So we're going to have our k value, but remember it has to be the opposite of h. Because that's positive, that tells me my h has to switch sign. It's actually going to be -3. And my h is negative. Does that mean left, right, up, or down? Left. H tells you left or right. So that's going to be left 3 units. And then the k value is after the fraction. So notice after the fraction, I don't have anything there. So my k value in this example is actually 0. And because that's a 0, that means I don't go up or down. So in this case, there's no vertical shift. I don't go left or right. I'm sorry, I don't go up or down. There's no vertical shift. And then the equations to my asymptotes, the vertical has to be x equals h. So I'm going to have x equals my h value of -3. And horizontal is y equals k. And my k value is 0, so I'm going to get y equals 0. So go draw your two dots. So on the x-axis, we're going to cross at -3. So grab your ruler, and we're going to cross at -3, making a dashed line. Again, you can use your highlighter if you want to so that it stands out. It has to be a dashed line though. And then I'm going to grab my ruler again, but this time I'm going to go to y equals 0. So on the y-axis, I'm going to go to the 0. And it has to be horizontal, so left to right. I'm going to draw a dashed line. So for my dashed line, it's basically going to be on top of the x-axis. So I have my x equals -3 and my y equals 0. Then I'm going to take my two key points. I have 1, 1 and -1, -1. And I'm going to first do an x-axis reflection. So first, you're going to flip it across the x-axis. So if it's on top, you move it to the bottom. If it's at the bottom, you move it to the top. So first you want to do your reflections, and then you're going to do your shifts. So then the second thing we do is going to go to the left 3 times. Okay? So I'm going to take my coordinate point of 1, 1 right here. I'm first going to flip it across the x-axis, so move it over down to -1. And then I'm going to go left 3 times. So 1, 2, 3. I should end up at -2, -1. And then do the same thing with -1, -1. First, flip it across the x-axis. So I got to flip it to the top, 1, 1. And then I go to the left, 1, 2, 3. And you should be at -4, +1. And again, notice my 2 points are across from each other. That should always happen. So to draw your curve, start next to the asymptote, go through the point, and end next to the other asymptote, next to the asymptote, through the point, next to the other asymptote. Question? So I got a curve upwards next to the asymptote. Likewise, this one next to the asymptote, touch the point, and next to the asymptote. Okay, and then that's it. That's the end of that example. All right, let's kick it up a notch, and we're going to do a little bit more. So go ahead and copy this one. G of x is 1 over x minus 5 and minus 2 at the end. All right, so I want you guys to go ahead and practice finding A, H, and K. So go ahead and figure out by yourself individually first what are your values for A, H, and K. And go ahead and righties, tell your partner what are A, H, and K. Righties? All right, so on a count of 3, can I have everybody tell me what is the value for A? Ready? Tell me in 3, 2, 1. 1. That was bad, you guys. I only heard like 2 people. A is 1. So again, no stretch, no compression, no reflection. No reflection, no stretch, and no compression. Let's try this one more time. I need everybody, on a count of 3, tell me what is the H value. Ready? Tell me in 3, 2, 1. 5. That was a little better, but that's still not everybody. If h is 5, does that mean left, right, up, or down? It's to the right. H tells you left and right. Sorry, your right is over here. Right? No, it was that way. Sorry. I have to like turn around because you guys are looking at a different way. But anyways, this is right 5. And then your K value. Everybody tell me on a count of 3 what's K. Ready? Tell me in 3, 2, 1. -2. Thank you. That was much better. So K tells you up or down. If it's negative, what does that mean? Down 2. All right, my equations to the asymptotes is x equals h. So I got x equals what? 5. And then for the horizontal, y equals k. So it's y equals what? -2. So grab your ruler and you're going to put at x equals 5. So on the x-axis, the value of 5. You're going to draw a dashed line going top to bottom. And then you need the next one at y is -2. So draw your dashed line at x equals 5. And your dashed line at y equals -2. All right, then we're going to take our 2 coordinate points, 1, 1, -1, -1. And this time, no stretch, compression, or reflection, but I am going to go to the right 5 times and then down 2 times. So go to the point 1, 1, go to the right 5, down 2. So 1, 2, 3, 4, 5, down 1, 2. So you should end up at 6, -1. And then -1, -1, you go to the right 5 times. So 1, 2, 3, 4, 5. Then down 1, 2. So you should be at 4, -3. And then draw your 2 curves. Again, the lines have to be next to the 2 asymptotes. And that's the graph there. All right, so the next examples, I want you guys to just practice. So I'm going to